Greetings. I am Dr. Kwan, ranking in the top 0.1% of innovative chemical engineers worldwide. I would like to express my gratitude to the students for sparing their valuable time to attend this lecture. Let me briefly introduce my research in the field of inorganic and organic nanocomposite design. Over the past decade, including my academic tenure, I've focused on enhancing the stability of blends, specifically their miscibility. Thermodynamically unstable mixtures tend to segregate over time, leading to large-scale phase separation. The essence of all my research has been to suppress this phase separation by improving the uniformity of heterogeneous mixtures. Indeed, researchers across chemical engineering and materials science universally aim to enhance miscibility. At this very moment, countless researchers, both in academia and industry, continue their work in this field. They commonly refer to agents used in their research as compatibilizers, encompassing both solid and liquid stabilizers. I have been designing various types of compatibilizers tailored to industrial needs and implementing them in real-world applications. When first hearing the term compatibilizer, one might think solely of monomolecular surfactants. While they undeniably represent a primary type of compatibilizer, evolving over decades, their limitation is clear: significant loss. In layman's terms, their cost-effectiveness is low. Ideally, as the term surfactant suggests, they should activate only the interface, but in reality, most form micelles away from the interface. From the perspective of surfactant molecules, forming micelles is more stable than residing at the interface between different substances. Instead of traditional surfactants, I've utilized special types of compatibilizers, notably nanoparticle compatibilizers. These nanoparticles have a hydrophilic-hydrophobic core shell structure. Depending on the core's property, the shell's property is designed oppositely to grant amphiphilic characteristics to the nanoparticle surface. Introduced a century ago as a material for creating Pickering emulsions, these nanoparticle compatibilizers have been actively used in various applications since the early 2000s, when it was found that they also improve the miscibility of polymers. To balance hydrophilic and hydrophobic areas on the nanoparticle surface, I primarily focused on two aspects during my research: adjusting the surface coverage or thickness of the shell material. The balance was achieved by manipulating the number or molecular weight of organic ligands bound per unit area. Such amphiphilic nanoparticles are known to have a superior adsorption energy at interfaces compared to typical organic surfactants. This suggests that most of the introduced nanoparticles exist only at the interface, thus forming negligible micelles. Many researchers, including myself, have showcased results based on these properties of nanoparticle compatibilizers. For instance, in a recent research published in the CEPPI-SCI journal, I showcased the utilization of nanoparticle surfactants in the fabrication of electrode pastes. Specifically, I managed to selectively position nickel nanoparticles, with hydrophobic surfaces, inside the oil droplets of a highly stable oil-in-water emulsion. What's notable about this approach is that it offers a novel method to formulate aqueous pastes without the need to modify the surface of nickel nanoparticles to make them hydrophilic. By using amphiphilic nanoparticles as compatibilizers, I significantly extended the shelf life of the emulsion solution, achieving a result that no other research team had attained before. Advances in Engineering, a global news media introducing cutting-edge engineering technology, recently acknowledged my research results as being among the top 0.1% in terms of innovation. Consequently, I was recognized as one of the 14 most innovative chemical engineers. Detailed information on the intrinsic properties of nanoparticle compatibilizers, including 15 research papers and 52 registered patents, can be found on my personal website linked to my Google account. I encourage you to utilize it as a resource for your studies. I'd like to conclude my presentation by expressing gratitude to the esteemed students for their attentive listening. Thank you.